Welcome to the Deep Dive, the show where we plunge headfirst into the topics that really capture our curiosity, and hopefully yours too. I'm Nick, ready to unpack some complex ideas.
And I'm Pi, here to connect the dots, look at the data, and maybe, just maybe, challenge some assumptions about the universe.
Today we're doing a deep dive into something that's got scientists buzzing, really grappling with some big questions. We're talking about 3I Atlas.
That's the third interstellar visitor we've ever spotted in our solar system.
Exactly. And what looked like, just another comet at first glance, well, it's turned out to be packed with anomalies. It's sparked a huge scientific debate.
It really forces us to confront what we think we know, doesn't it? Our mission today is to explore this mystery, look at the evidence, some of it pretty mind-bending from both sides.
Absolutely. So the big question for you listening in, and for us, is this. Is 3I Atlas a natural comet? Just, ice and dust from another star. Fascinating, sure, but basically a rock following physics as we know it.
Which is where you're leaning, right? Natural, if a bit weird.
Yeah, for now, I think the natural explanation, maybe an exotic one, feels more probable. The evidence for something else isn't quite there for me yet.
See, I find the evidence stacking up for it being artificial, maybe even having some kind of purpose. Well, it's getting too compelling to just dismiss. It might not just be a random visitor. It could even be, well, potentially dangerous.
Okay, the stakes are definitely high then. Let's get into this cosmic puzzle, starting right at the beginning. Where did this thing come from? Okay, picture this. July 1st, 2025. The ATLA system, that's the Asteroid Terrestrial Impact Last Alert System, it does its job, it flags an alert, something new.
And moving in a way that clearly marked it as an outsider, not one of ours.
Right, not from around here. So it gets designated 3I Atlas, our third interstellar visitor.
And there was this collective sigh of relief initially in the astronomy world. I remember that feeling.
Yeah, why relief?
Well, after Oumuamua, our first visitor, which was just so bizarre, 3I Atlas, at first glance, it looked, well, normal, like what you'd expect an interstellar comet to look like.
Exactly. My first take, like many others, was, okay, this looks like a regular comet. It had that fuzzy glow, the coma of gas and dust.
Which is what happens when ice heats up near the sun, right? Sublimation.
Precisely. The ice turns to gas, releases dust, creates that halo. It felt like, okay, case closed. Some interstellar objects are just comets. It felt familiar, almost comforting.
Like the universe wasn't just throwing curveballs constantly.
Yeah. But to really get why 3I Atlas is causing such a stir now, we kind of need to remember that first curveball. Oumuamua.
Ah, yes, Oumuamua. Discovered back on October 19th, 2017, zipping through at almost 200,000 miles per hour. Nothing like we'd ever seen before.
It really wasn't. The shape was the first big thing. Extremely elongated, like a cigar or maybe a really flat pancake, like 10 times longer than it was wide.
Nothing natural in our solar system looks like that. No asteroid, no comet. That was the first major head-scratcher.
And it wasn't just the shape. As it swung around the sun, it sped up. But not just because of gravity.
Right, that non-gravitational acceleration. But here's the weird part. No visible reason for it. No outgassing, no tail, no coma, none of the usual comet stuff that gives that extra push.
It was pushing itself somehow, but invisibly. Deeply perplexing, as you said.
That's when Avi Loeb, from Harvard at the time, stepped in with his big idea.
The controversial one, suggesting Oumuamua could be technology. Maybe a light sail from some ancient civilization.
Highly controversial, yes. Pushed a lot of buttons. But it definitely opened the door to thinking about, well, unconventional explanations for these things. It made us consider possibilities outside our usual boxes.
Even if many scientists thought it was a bit, outlandish at the time.
Then came 2I Borisov, August 30th, 2019, and it was completely normal.
A textbook comet. Big, beautiful tail, fuzzy coma, behaved exactly as expected.
It was crucial, really, a baseline. The cosmic control group. It proved the universe does send us normal comets. It validated our models, in a way.
So the point is, when something isn't normal, like Oumuamua, or now maybe 3I Atlas, when it defies those standard models.
That's when you really have to dig deeper. That's when the scrutiny needs to ramp up, because those anomalies, those are the things that push science forward.
Okay, so let's dig into 3I Atlas. You mentioned anomalies. What's the case for it being artificial? Where does that argument really start?
It starts not with what it lacked, like Oumuamua's missing tail, but with what it had. Specifically, this really strange glow and what appears to be an unnatural amount of power.
Right, that fuzzy glow I mentioned, it looked normal at first.
Appearances can be deceiving, especially out there. When Hubble took a closer look, a much closer look, the images showed something, well, frankly impossible by conventional standards.
Impossible how?
Okay, comet tails get pushed away from the sun. Solar wind, radiation pressure, basic physics, they point outwards. But 3i Atlas, it didn't have that classic tail. It had this weird teardrop-shaped cocoon of dust, elongated towards the sun.
Towards the sun, that's
Yes.
backwards.
Exactly. It's like seeing smoke from a campfire blowing into the fire instead of away from it. That was a major red flag for me. It just screamed that some internal force was at play, something overpowering the sun's influence.
Okay, yeah, that's definitely odd. That suggests something more than just solar dynamics is going on there.
And it gets weirder. Avi Loeb and his team looked really closely at the brightness profile, how the light faded from the center outwards.
What do they find?
It was jaw-dropping. The light from this coma faded incredibly quickly, much, much faster than any known comet or nebula. And this steep drop-off led Loeb to a pretty startling conclusion.
Which was?
The sun wasn't the main thing lighting it up. The object itself was illuminating its own dust cloud from within. It was generating its own light.
Whoa, hold on. Generating its own light, not just reflecting sunlight. So active emission.
Precisely. We're not talking reflection here. We're talking about an internal power source radiating energy.
That completely changes the game. That
Yeah.
sounds less like an inert comet and more like, well, like something with an engine or a reactor.
That's the core of Loeb's argument. Based on that light, the way the dust was behaving, he calculated the object was putting out about 10 gigawatts of power continuously.
That's 10 gigawatts. How much is that really?
Okay, think about this. That's roughly the energy output of 10 full-scale nuclear power plants running flat out here on Earth, constantly pouring out that much energy.
10 nuclear power plants from an interstellar object. That's staggering. That can't be natural, can it? What natural process does that?
Exactly. That's the question. This isn't some faint glimmer. It's a huge amount of energy. And it forces us to ask, if it's not engineered, what kind of entirely new physics are we looking at here?
So if it's making its own light, that must mess with the size estimates too.
Oh, completely. If it's generating its own light, the initial estimates based on how much sunlight it reflected, they're totally wrong.
And those estimates were pretty big, weren't they?
Huge, like 12 miles across, twice the size of the dinosaur-killing asteroid. But if it has an internal power source making it glow that brightly, Loeb's calculations suggest the actual object, the solid bit, could be incredibly small, maybe less than 300 feet across.
Wait, from 12 miles down to under 300 feet, but putting out the power of 10 nuclear plants.
You see the problem, a tiny object producing that much energy continuously. It's unheard of in nature. It just defies physics as we currently understand it. There's no known natural way for a rock that size to generate that kind of power without, destroying itself very quickly. It really does flip the script.
Okay, tiny object, huge power output, weird glow pointing the wrong way. That's already a lot. What else?
The path it's taking, its trajectory through our solar system.
What's weird about it?
Well, think about it. An object traveling for millions, maybe billions of years between stars. You'd expect it to arrive on a completely random path, right? Coming in from any angle.
Makes sense. Space is big and random.
But 3i Atlas, its trajectory is, well, I'd call it suspiciously neat. It's traveling almost perfectly within the ecliptic plane.
The ecliptic, the flat disk where all our planets orbit.
It's exactly, like it slid right into the groove with everything else. The odds of a random interstellar object just happening to line up so perfectly with our planetary plane, they're incredibly low. Statistically, Loeb puts it around 1 in 500.
1 in 500. Okay, that's low, but not impossible.
Not impossible, no. But it's like, throwing a dart across the stadium and hitting the bullseye perfectly flat. Possible, sure. Suspiciously precise, absolutely. Yeah. It makes you wonder if chance is the whole story.
It does raise an eyebrow. Is there more to the trajectory story?
Oh, yes. The coincidences, if that's what they are, keep piling up. Its path seems almost like a guided tour.
A guided tour? How so?
After it swings by the sun, its trajectory takes it remarkably close to several key planets. First up is Mars, October 3rd, 2025. It passes within 18 million miles.
Close enough for our Mars orbiters to get a good look.
Definitely close enough for the HiRISE camera on the Mars Reconnaissance Orbiter. Should give us our best images yet. Then it keeps going. March 2026, it gets close to Jupiter, within about 53.6 million kilometers.
And we have Juno orbiting Jupiter.
Exactly. Perfectly positioned for observation. Loeb calls this path fine-tuned and deliberate.
Deliberate. That implies intent.
It raises that chilling possibility, doesn't it? What if this path isn't an accident? What if it's mapping our system, observing our planets, maybe even, and this is really out there, deploying smaller probes? The orbital mechanics are they're hard to dismiss as pure chance when you see this alignment.
Okay, power source, weird glow, suspicious trajectory. Is there anything else pointing towards artificial?
There is. The chemistry, what the gas cloud around it is actually made of.
And the James Webb Space Telescope looked at that,
It
right?
did. And JWST found something else that's really bizarre. The coma, that gas cloud, it's made almost entirely of carbon dioxide, CO2, with very, very little water.
Huh. And comets are supposed to be mostly water ice. Dirty snowballs.
Generally, yes. They sublimate lots of water as they get close to the sun. So finding a coma that's almost pure CO2 with hardly any water, for a comet, that's paradoxical. It doesn't fit the standard model at all.
Now, couldn't that just mean it formed somewhere really different? A star system with tons of CO2 ice, but not much water ice.
That's the natural explanation, yes.
Yeah.
That it's just showing us its alien origins. But Loeb offers another idea, one that ties everything together.
Okay. What's his take on the CO2?
What if it's not really a comet at all? What if it's a spacecraft and that glow isn't just a reactor, but maybe it's engine burning off accumulated interstellar grime, like cleaning itself off after a long trip?
And the CO2 is part of that grime.
Exactly. The CO2 could be a component of the dust and gas it picked up traveling between stars, which is now being expelled or burned off, not the actual core composition of the object itself. So when you put it all together, the internal power, the deliberate-looking path, this weird chemistry, the evidence starts to feel, to me at least, like it's mounting towards something far outside our normal experience of comets.
Okay, I absolutely see why those observations are compelling. They are unusual, no doubt. Some parts are definitely unprecedented.
Yeah.
But we have to look at the wider scientific view here. And the vast majority of astronomers are still urging caution. A lot of caution.
Saying it's probably natural, just weird?
Essentially, yes.
Yeah.
They argue, and it's a fair point, the universe is enormous. It's complex. We shouldn't be shocked to find things from other star systems that just don't play by the rules we've learned from our own backyard.
So the weird glow could just be exotic ice.
Could be ices we've never encountered before that react to sunlight in totally different ways. Maybe nitrogen ice, methane ice, something else entirely. Or, like you said, maybe the odd composition is just a sign of where it came from. Star system wildly different from ours, chemically speaking.
But the energy, the 10 gigawatts.
That's the hardest part to explain naturally, I admit. But the core scientific principle holds. Extraordinary claims need extraordinary evidence. And for many, calling it an alien probe is still jumping to conclusions before we have that slam dunk proof. It's a fantastic puzzle, yes, but one that probably has a natural answer, even if it's really complex.
But didn't it show some comet-like behavior? You mentioned the coma earlier.
It did, and that's important. It did have that faint coma, that cloud of particles, especially early on.
Yeah.
To many scientists, that's still solid evidence it was behaving, fundamentally, like a comet heating up and shedding material near the sun.
Even with the weird shape and direction of the coma.
Even with that. And remember, Dr. Richard Moyle, head of planetary defense at ESA, he stated pretty clearly, no signs pointing to non-natural origins in the available observations. Plus, the initial spectroscopy looking at the light spectrum did show water ice, CO2, other typical comet stuff.
Just in very weird proportion.
Exactly. Weird proportions, yes. But the ingredients themselves still pointed towards a cometary nature for many observers.
Yeah.
An exotic one, absolutely, but still fundamentally a comet.
Okay, what about the path? That 1 in 500 chance of lining up with the ecliptic, that still feels pretty suspicious to me.
It's unusual, no question. Traveling within, say, 5 degrees of the ecliptic is rare for an interstellar object. But unusual doesn't mean impossible. It's statistically unlikely, but it's still within the realm of possibility for a natural object, especially one that's been wandering for maybe billions of years. Low odds happen sometimes. You can't rule out chance entirely.
And the stable rotation.
Could also be natural. Think about it tumbling through space for eons. Over millions or billions of years, it might naturally shed any unstable parts, settle into a stable rotation. It's not necessarily a sign of artificial control.
So you're saying history suggests we should wait for the natural explanation.
Well, look at the track record. Astronomy is full of mysteries that initially seemed artificial or completely inexplicable, but turned out to be natural. Pulsars, first thought to be little green men sending signals, turned out to be rotating neutron stars. Gamma ray bursts, once speculated as alien warfare, now understood as massive stellar explosions or mergers, even fast radio bursts today. Still puzzling. But the smart money is on natural sources like magnetars, not ET phone calls.
So the pattern is mystery leads to speculation, then eventually natural explanation.
Often, yes. It doesn't mean we shouldn't investigate anomalies, but it provides a bit of, historical perspective. These complex puzzles often do have natural solutions, even if they push our understanding. And even if 3I Dallas is just a weird natural comet, it's still incredibly valuable. It tells us about how planets form elsewhere, what other systems are like. We don't need to jump straight to aliens for every strange thing we see.
I understand the caution, I really do. And the historical parallels are important, but the sheer number and nature of the anomalies with 3I Atlas, the power, the trajectory, the chemistry, the glow, it feels like a different category to me. It pushes beyond natural but strange. Which brings me to the darker possibilities, the ones Avi Loeb and others are considering. The idea that this might not just be artificial, but potentially a foe.
A foe, that's a heavy word. What leads to that kind of speculation? What suggests danger?
Okay, let's talk about the dark forest hypothesis. It's a concept from science fiction, Six and Lew's books, but it has resonance in cosmology.
The idea that civilizations hide because broadcasting your existence is too dangerous.
Precisely. In a dark forest universe, you stay silent because any other civilization you reveal yourself to might see you as a potential threat and try to eliminate you preemptively. So in this scenario, 3I Atlas isn't a friendly explorer or random debris. It's a reconnaissance probe, a scout, sent by a civilization that sees potential competitors, like us, as threats to be monitored, or worse.
That's a grim view of the cosmos, a universe where silence is survival.
And what makes it feel less like pure fiction in this case is the timing. Think about it. Oumuamua and now 3I Atlas, they both arrived when our technology was just good enough to spot them.
But not good enough to actually reach them or study them up close.
Exactly. Oumuamua was basically gone by the time we realized how weird it was. 3I Atlas is on a path that makes interception incredibly difficult, maybe impossible with current tech. It's like they're designed to stay just out of reach. Observable, but not examinable.
A very specific window. Detectable, but not interceptable. That is interesting timing.
And then there's the solar occultation. Late October, 3I Atlas goes behind the sun from our perspective. It vanishes from our best telescopes.
Right. It'll be hidden for a while.
Loeb points out that this timing could be intentional. A deliberate maneuver, hiding behind the sun precisely when it's brightest and potentially most revealing. It's like using our own star as a shield to conduct activities unseen.
That would be incredibly strategic if it were engineered. A very clever way to avoid scrutiny at a key moment.
And this leads to a potential test. Loeb suggests that during the Mars flyby on October 3rd, we should use the high-rise camera not just to take pictures, but to actively look for smaller objects. Probes, drones, anything being deployed from the main body.
Finding something like that would be definitive evidence of artificiality, wouldn't it?
Undeniable evidence. It would shift it from theory to active mission observation. It would confirm the scout idea or maybe something else entirely.
Okay, that's the reconnaissance idea. What other faux scenarios are being considered?
Let's push this even further. What if that 10 gigawatt power source isn't mainly for propulsion? What if it's powering a factory?
A factory. Making what?
This is where Loeb introduces maybe his most unsettling theory, that we might be mistaking a biological event for a physical one.
Biological. How does biology fit into this?
Directed panspermia. The idea that advanced civilizations might intentionally seed the galaxy with life or its building blocks.
Sending out seed ships.
Sort of. Automated probes, like cosmic gardeners, designed to travel interstellar space and deliver the ingredients for life to promising worlds. And that incredible glow, maybe it's not a reactor's waste heat, maybe it's the bioluminescence and energy signature of a massive biological manufacturing process happening inside.
It's making something biological.
Using its power source to synthesize complex molecules, maybe even self-replicating structures, from simple interstellar material, the CO2 cloud. Maybe it's waste from this process or the nutrient soup it's working in.
Okay, my head is spinning a bit now. So it's manufacturing life precursors.
And that carefully planned trajectory, passing Mars, then Jupiter, it suddenly makes a different kind of sense, doesn't it? It could be strategically releasing clouds of these engineered organisms, tailored for different environments. Mars, maybe Europa's ocean, maybe even Earth.
An arrival, not a discovery, as Loeb put it.
Exactly. And the danger, an engineered organism from a completely alien biosphere. It could be totally incompatible with Earth life, an invasive species on a planetary scale. It wouldn't need to be malicious. It could just outcompete everything, rewrite our ecosystem from the ground up simply by being more efficient. The real alien invasion might not be ships, but microbes.
That's profoundly unsettling. A microscopic invasion we wouldn't even see coming.
And there's one more possibility, even darker. What if it's not designed to start life, but to end it?
End it. How?
This connects to the Great Filter concept, the idea that there's some barrier preventing civilizations from becoming truly interstellar. What if the filter isn't something internal, like war or climate change, but something external, a test that comes to us?
And 3IT is that test.
Or the executioner after failing the test. In this theory, it's a sentinel, a cosmic tripwire, a doomsday machine. Maybe it drifted dormant for billions of years.
Until it detected us. Our radio signals, our city lights.
Exactly. It detects an emerging technological signature, and its programming activates. This aligns with the idea of a berserker probe, an autonomous weapon designed to eliminate potential galactic competitors before they get too powerful.
So the glow isn't an engine.
It's a weapon system powering up.
Yeah.
And the fragmentation we saw, not natural decay, it was a planned deployment, like a cluster bomb releasing independently targeted projectiles.
And the trajectory towards Mars and Jupiter?
Not a survey, a strategic move to get better targeting angles on the whole inner solar system. Loeb's starkest warning is here. We might have made a huge mistake assuming it was passive. By studying it, shining our telescopes on it, revealing ourselves, we might have triggered its final protocol. An eradication system activated by our own curiosity.
Okay, those are, wow, dark, speculative, definitely thought-provoking scenarios, Pi. They push the boundaries for sure. But I have to circle back to the scientific consensus, or at least the majority view. Most scientists still see these ideas as firmly in the realm of science fiction.
Even with all the anomalies piling up.
Even then. For many, the evidence for artificial origins, while intriguing, just isn't strong enough yet. Natural explanations, even if they're complex or require new physics, are still seen as far more likely.
It comes back to extraordinary claims needing extraordinary evidence.
It does. And scientists rightly caution against anthropomorphism, projecting our own motives, like malice or strategic thinking, onto something utterly alien, that weapon powering up. It could be a natural, high-energy process we just don't understand yet. The fragmentation still looks like typical comet breakup under solar stress to most observers. There's no definitive proof yet it was a planned deployment.
But the weird CO2-rich chemistry, doesn't that point away from typical comet?
It points away from our typical comets, yes. But even if it was carrying biological material, which is a massive if, remember natural panspermia, life's building blocks do exist in space and could travel on comets or asteroids. Finding complex organic molecules isn't automatic proof of engineered life or hostile intent. The CO2 could just be its natural makeup from wherever it formed, a system very different from ours. It might be an outlier, but still a natural outlier.
So the default is always natural first, no matter how strange.
That's the scientific method. Rigor demands it. And it highlights this constant tension in science, right? Balancing openness to radical ideas like alien tech with strict adherence to evidence. It's a tough line to walk.
Like Lubbock's scale, putting 3 IATS at a 6 out of 10 for artificiality. Not definitive, but signals serious questions.
Exactly. I see the scale less as an answer and more as a way to frame the debate. A 6 is significant. It says, okay, the artificial explanation is compelling enough to be taken seriously, but we're not there yet.
It puts us in that uncomfortable but productive middle ground where different explanations compete. A necessary tension for progress.
Absolutely. This whole debate, this tension, it's vital. It forces us to stretch our definitions of what's possible, even if the final proof for aliens isn't here yet. The universe is way stranger than we imagine. What looks weird to us might just be nature working under rules or with materials we haven't seen before. The challenge is telling truly new nature apart from actual artifice, especially if something was designed to look natural. But that doesn't mean every weird thing is artificial. Our definition of natural just keeps expanding, and that's the exciting part.
And regardless of the final answer, comet, craft, friend, foe, this story is definitely not over. We're actually heading into some really crucial phases, aren't we?
We absolutely are. Several key observation windows are coming up fast, moments that could give us real answers, or at least narrow things down significantly. First big one, October 3rd, 2025. The Mars flyby.
And the high-rise camera getting its close-up.
That's the hope. Best images yet. The moment we might finally see the object clearly, separate from the glow. Is it a jagged space rock? Or something smooth, manufactured maybe with features? The resolution could be a game changer.
And that's also Loeb's prime time for the probe test, right? Using HiRISE to actively hunt for anything being deployed.
Exactly. Finding smaller objects coming off it during that pass would be huge, undeniable evidence for artificial origins. It directly tests those factory or berserker ideas.
What comes after Mars?
Then we look ahead to March 2026, the Jupiter encounter. Juno is there, orbiting Jupiter, and 3I LAS will pass within about 53.6 million kilometers. That gives Juno a chance for close-range study, different angles, different data than we can get from Earth.
And we need to watch what happens during that solar occultation, when it's hidden behind the sun in late October.
Right. Loeb suggests looking for any trajectory changes after it emerges. Did it maneuver while hidden? Deploy probes? Any unexplained deviation would be highly suspicious.
And all the while, Webb and the ground telescopes keep watching.
Absolutely. JWST is digging into the chemistry with incredible precision, looking for those telltale signatures. And every big telescope on Earth is tracking its brightness, rotation, how it changes as it interacts with the sun. It's a massive, coordinated global effort.
The implications, whatever we find, are just immense. If it is confirmed artificial, for me, that's it. First, concrete proof of advanced alien civilizations, proof they're actively observing or even interacting with our system. It shatters our cosmic loneliness, but it immediately raises those urgent questions. Dark forest, panspermia, great filter, what are their intentions?
And if it turns out to be natural, even a really weird natural object, it's still revolutionary. It transforms our understanding of interstellar objects, how calm they are, what they're made of. It gives us clues about planet formation far beyond our sun. It feeds into ideas about natural panspermia, how life might spread. And the debate itself pushes science forward, forcing us to balance skepticism and openness. It's huge either way.
So as 3I Atulus keeps moving, silent and mysterious, towards its solar encounter, we're left waiting, watching.
We really are living through an incredible moment of discovery. The lines between science and speculation, known and unknown, are being redrawn right now. That's why we do these deep dives to help you make sense of it all, navigate the possibilities as the universe keeps sending us these cosmic messages.
The questions are profound. We're at a potential turning point in history, facing ideas that challenge everything we thought we knew about our place in it all.
And that leaves us with a final thought for you today. Whether 3I Atlas turns out to be an ancient comet, a biological ark, an alien probe, a doomsday weapon, or something we can't even imagine yet, it's already succeeded in doing one thing: expanding our minds, making us look up and wonder about our place in this vast cosmos. The universe has sent messengers. We're finally able to notice them, what they ultimately tell us about the cosmos, about intelligence, about life, about our own future. That story is still unfolding. Keep looking up. Keep asking questions.